Hey everyone, welcome. Today we're going to do something really cool. We're going to build a smart circuit, but get this, without any complicated coding or microcontrollers. This is pure, simple electronics that actually thinks for itself. So let's dive right in. Hey, welcome back to our third session together. I'm so glad you're here. Whether you've been with me from the start or you're just jumping in, today is gonna be a good one. We're taking a huge step forward on our electronics journey by building something you can actually use. So I've got to ask you something. What if your lamp, what if it just knew when you needed it? Imagine it could sense the room getting dark and just turn itself on. All by itself. Sounds like magic, right? Well, that's not magic. It's exactly what we're building today. So here's the plan for today. First, we'll talk about the goal. Then we'll gather our toolkit and get to know the components. After that, it's the fun part, the step-by-step build, followed by the moment of truth, testing it out. And we'll wrap up with some troubleshooting and a peek at what's coming next. It's a straight shot from an idea to a working device. Okay, first up, the project goal. What are we actually trying to do here? Well, it's actually beautifully simple. We are creating a light that responds to its own environment. This is like the foundational concept behind all smart technology. And we're going to build it with just a few parts. And you know what? The logic behind this whole thing is super simple. Just look at this. When it gets dark, the LED turns on. When it gets bright, the LED turns off. That's it. It's a basic if this, then that decision, and we're making it all happen with hardware. No code involved. All right, it's time to get our toolkit ready. You know, just like a chef gathers all their ingredients before they start cooking, that's what we're going to do now. Let's get our electronic components all lined up. Here's what you're going to need. We've got one LED, an LDR, that's our light sensor, a BC547 transistor, two different resistors, a 9-volt battery, a handful of jumper wires, and of course, our trusty breadboard. That's our canvas. Go ahead and hit pause right here if you need a second to gather all your parts. All right, you got everything? Perfect. Let's get to know the key players in our circuit. Seriously, understanding what each little part does is the key to understanding how the whole thing works. And don't worry, we're keeping it simple. First up, we've got this little guy right here. This is the LDR, which stands for light-dependent resistor. The easiest way to think of it is as the circuit's eye. Its one and only job is to see how bright or dark the room is. It's pretty cool, right? All right, next up is the real star of the show, the BC547 transistor. If the LDR is the eye, then this guy is the brain. It takes the signal from the eye and makes a decision. It acts like a tiny automatic switch, deciding whether to let electricity flow to turn the LED on or off. And finally, we've got our resistors. Now, these guys are kind of the unsung heroes of the circuit. I like to call them the protectors. They're like little traffic cops for electricity, making sure that our more delicate parts, like the LED, don't get too much power and burn out. They keep everything running safely. Okay, everybody, stop what you're doing for a sec. This next part is super important. Pick up your transistor and make sure you hold it with the flat side facing you. The pins going from left to right are collector, base, and emitter. Just remember CBE. Getting this right is honestly the key to the whole project. All right, enough talk. We know our parts. We know the goal. It is time to get our hands dirty. Well, not really, but you know what I mean. Let's get building on that breadboard and bring this thing to life. Let's get wiring. First things first, let's get some power to our board. Connect the red wire from your battery clip to the positive rail and the black wire to the negative or ground rail. Easy. Next, carefully push that transistor into the board. Make sure its 3 little legs are all in different rows. And then, take a jumper wire and connect the emitter pin, that's the one on the far right, straight to the ground rail. Okay, now for the fun part, the part that actually lights up. Grab your LED. Remember the rule? Long leg is positive, short leg is negative. Connect that short, negative leg to the collector pin of the transistor. That's the one on the left. Then, the long leg connects to one end of our 330 ohm resistor, and the other end of that resistor goes to the positive power rail. Done. We are so close. This is the step where we add the smarts to our circuit. Take your LDR, our eye, and connect one of its legs to the positive power rail. The other leg goes to the base of the transistor, that middle pin. Then grab your 10K ohm resistor and connect it from that same base pin down to the ground rail. This little setup right here is what actually senses the light. Okay, before we plug in that battery, let's just take a breath and do one final check. Think of this slide as your cheat sheet. That whole setup we just made with the LDR and the 10K resistor, That's called a voltage divider, and it's the secret sauce that tells our transistor's brain what to do. So go ahead, pause here, and just trace every single wire one last time. Trust me, it's worth it. All right, you double-checked everything? Are all the wires pushed in nice and snug? Components facing the right way? Okay then, it's time. This is the moment we have been building up to. Let's see if our little circuit is ready to come alive. Take a deep breath. Are you ready for this? Let's find out what you've made. Let's do it. Okay, go ahead and snap on your 9-volt battery. Now just gently cover the LDR with your finger, just to make a shadow over it. Did the LED turn on? It should be glowing. Look at that. Now take your finger away. Or even better, shine your phone's flashlight on the LDR. The LED should turn off. On in the dark, off in the light. It works. Yes, you did it. That is awesome. Give yourself a pat on the back. Seriously, that is fantastic. You didn't just plug in some wires. You built an intelligent electronic system from scratch that can sense the world around it and make a decision. That is a huge, huge deal. Okay, now if your circuit isn't working just yet, please do not panic. It happens to all of us, I promise. Building electronics is all about solving little puzzles. So let's run through a few common fixes real quick, and then we'll look ahead. 9 times out of 10, it's one of these simple things. First, is your LED in backwards? Remember, long leg is positive. Second, are you sure you got the transistor's collector, base, and emitter pins right? And here's a big one. Are all your wires and components pushed all the way into the breadboard? A loose wire is the #1 culprit. Just double check those things. You all did amazing work today. You built something real, something you can hold in your hand. Now that you've done it in the real world, you're ready for the next level. We're going to learn how to design, build, and test circuits right on your computer before you even buy a single part. It is an absolutely essential skill for any maker, and I can't wait to show you how it works. In the next video, I will teach about simulation apps.